NEC Table 310.104 does not list XHHW or any equivalent single conductor cable in number 16 AWG for outdoor use. In this situation, TFFN-2 cable type could be considered as an acceptable equivalent for outdoor industrial applications. This cable is rated for outdoor use, wet or dry locations, and has a voltage rating of 600 volts. It is also suitable for use in rigid metal conduit. Machine tool wire, tray flame retardant, and flame resistant nylon cable is primarily intended for indoor use in industrial applications such as control circuits in machinery. It is not specifically rated for outdoor use and may not withstand the harsh conditions encountered in an outdoor industrial environment. Based on the information provided, using machine tool wire, tray flame retardant, and flame resistant nylon cable for an outdoor industrial application is not recommended. Instead, TFFN-2 cable would be a more suitable choice as it is specifically rated for outdoor use and meets the requirements of NEC Article 310.104. Let's delve a little deeper into the specifics of these cables and their suitability for different environments. We'll begin with XHHW, or cross-link polyethylene high-heat resistant water-resistant wire. This type of insulation is commonly used in building wire due to its excellent resistance to heat and moisture. However, it's important to note that NEC Table 310.104, which outlines allowable ampacities for conductors, does not list XHHW in number 16 AWG. This means that according to the code, you cannot use XHHW number 16 AWG for general wiring purposes. This is where the search for an equivalent begins. The alternative that has been suggested is TFFN-2. TFFN-2 stands for thermoplastic high water resistant nylon coated wire, and the 2 indicates that it has a higher temperature rating and is suitable for wet locations. TFFN-2 is a popular choice for a variety of applications because of its versatility and durability. It is specifically designed to withstand harsh conditions, including exposure to moisture and extreme temperatures. The voltage rating of 600 volts means that it can safely handle the electrical loads typically found in industrial control circuits. TFFN-2's suitability for use in rigid metal conduit is another important factor. RMC provides excellent mechanical protection for the conductors, safeguarding them from physical damage and environmental hazards. The combination of TFFN-2 and RMC creates a robust and reliable wiring system that can withstand the rigors of an industrial setting. Now let's turn our attention to machine tool wire, tray flame retardant, and flame resistant nylon cable. This type of cable, often abbreviated as MTW, is commonly used in machine tools and other industrial equipment. It is designed to be flexible and resistant to oil, chemicals, and abrasion. However, machine tool wire, tray flame retardant, and flame resistant nylon cable is primarily intended for indoor use. It is not specifically rated for outdoor applications, and it may not be able to withstand the effects of sunlight, rain, and extreme temperatures. The nylon jacket, while offering some protection against abrasion, is not as resistant to environmental degradation as the insulation found in TFFN-2 cable. In an outdoor industrial environment, cables are exposed to a wide range of harsh conditions. These can include ultraviolet radiation from the sun, which can cause the insulation to break down over time. Moisture can also penetrate the cable and corrode the conductors. Extreme temperatures, both hot and cold, can also affect the performance and longevity of the cable. Given these factors, it is generally not recommended to use machine tool wire, tray flame retardant, and flame resistant nylon cable for outdoor applications. While it may be tempting to use it due to its availability or lower cost, it is important to consider the long-term consequences of using a cable that is not specifically designed for outdoor use. The potential for premature failure, electrical hazards, and costly repairs outweighs any short-term savings. In conclusion, when selecting a cable for outdoor industrial applications, it is essential to choose one that is specifically rated for the environment. THWM-2 cable is a suitable choice as it meets the requirements of NEC Article 310.104 and is designed to withstand the rigors of outdoor exposure. While machine tool wire, tray flame retardant and flame resistant nylon cable may be appropriate for indoor applications, it is not recommended for outdoor use. By using the right cable for the job, you can ensure a safe and reliable electrical system that will provide years of trouble-free service. Let's consider the impact of using the wrong type of wire in an outdoor industrial setting. Firstly, premature cable failure is a significant concern. Exposure to ultraviolet radiation, moisture, and extreme temperatures can cause the insulation to degrade and crack, leading to short circuits, ground faults, and even electrical fires. Secondly, safety hazards are increased when using the wrong wire. A compromised cable can create a path for electricity to flow to unintended objects, posing a shock hazard to workers and the public. Thirdly, downtime and lost productivity can result from cable failures. When a cable fails, the equipment it powers will shut down, leading to production delays and costly repairs. Fourthly, compliance issues can arise from using non-compliant wiring. Electrical codes such as the NEC are designed to ensure the safety and reliability of electrical systems. Using the wrong type of wire can violate these codes, resulting in fines and penalties. To avoid these problems, it is essential to carefully consider the environmental conditions and the specific requirements of the application when selecting a cable. Consulting with a qualified electrician or electrical engineer can help ensure that the right cable is chosen for the job. When it comes to selecting THWM-2 cable, there are a few additional factors to consider. Firstly, conductor material is important. THWM-2 cable is typically available with either copper or aluminum conductors. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum is lighter and more affordable, but it requires larger conductors to carry the same amount of current as copper. Secondly, insulation thickness is a key factor. The thickness of the insulation affects the cable's ability to withstand voltage stress and protect against moisture and chemicals. Thicker insulation generally provides better protection, but it also makes the cable larger and more difficult to work with. Thirdly, jacket material is also important to consider. The jacket protects the insulation from abrasion, sunlight, and other environmental factors. Common jacket materials include polyvinyl chloride and polyethylene. Polyvinyl chloride is a versatile and cost-effective material, while polyethylene offers superior resistance to sunlight and chemicals. Finally, proper installation practices are essential for ensuring the long-term reliability of any wiring system. This includes using the correct size conduit, properly supporting the cables, and making sure that all connections are tight and secure. Regular inspections and maintenance can also help identify and address potential problems before they lead to cable failures. In addition to THWM-2, there are other types of cables that may be suitable for outdoor industrial applications depending on the specific requirements of the installation. These include firstly, USM-2 or underground service entrance cable. USM-2 is designed for direct burial in the ground and is highly resistant to moisture and chemicals. Secondly, RHW-2 or rubber high heat resistant water resistant cable. RHW-2 is similar to THWM-2 but has a rubber insulation that provides greater flexibility and resistance to abrasion. Thirdly, XLP or cross-linked polyethylene cable. XLP is a versatile cable that can be used in a wide range of applications, including direct burial and conduit installations. When selecting a cable, it is important to consult the NEC and other applicable standards to ensure that it meets all of the requirements for the intended application. It is also important to consider the specific environmental conditions and the potential for exposure to moisture, chemicals, and extreme temperatures. Remember, the goal is to choose a cable that will provide safe, reliable, and long-lasting performance in the intended environment. This may involve a slightly higher upfront cost, but it will ultimately save time, money, and headaches in the long run. Now let's talk more about the specific NEC requirements related to conductor selection. NEC Article 310 covers conductors for general wiring. This article specifies the types of conductors that are permitted for use in different applications, as well as their ampacities and other characteristics. NEC Table 310.16 provides the allowable ampacities for insulated conductors rated up to 600 volts, based on their temperature rating and the ambient temperature. It is important to consult this table to ensure that the conductors you select are capable of carrying the intended load without overheating. NEC Article 310.15 covers ampacity adjustment factors. This section specifies the factors that must be applied to the allowable ampacities in Table 310.16 when conductors are installed in certain conditions, such as when they are bundled together or when they are exposed to high ambient temperatures. NEC Article 310.104 lists conductor application and insulations. When selecting conductors, it is important to consider the voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and can even damage the conductors themselves. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to use conductors that are large enough to carry the intended load and to keep the length of the conductors as short as possible. In addition to the NEC, there may be other applicable standards and regulations that govern the selection and installation of conductors. These may include local building codes, industry standards, and manufacturer's specifications. It is important to be familiar with all of the applicable requirements and to ensure that the wiring system is designed and installed in accordance with those requirements. When in doubt, it is always best to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to help you select the right conductors for your application and to ensure that the wiring system is installed safely and correctly. Let's expand on the practical implications of selecting THWN-2 for outdoor industrial applications. First, consider the long-term cost savings. While THWN-2 might have a higher initial price compared to machine tool wire, tray flame retardant and flame-resistant nylon cable, its superior durability and resistance to environmental factors translate to fewer replacements and repairs over time. This reduces maintenance costs and minimizes downtime, leading to significant cost savings in the long run. Second, think about improved safety. By using a cable specifically designed for outdoor use, you reduce the risk of electrical hazards such as short circuits, ground faults, and electrical fires. This protects workers and equipment, creating a safer working environment. Third, consider enhanced reliability. THWN-2's ability to withstand harsh conditions ensures that your electrical system operates reliably, even in demanding industrial environments. This minimizes disruptions to production and helps maintain consistent performance. Fourth, compliance with regulations is critical. Using THWN-2 demonstrates compliance with the NEC and other applicable codes and standards. This avoids potential fines, penalties, and legal liabilities. Fifth, ease of installation is also an important factor. THWN-2 is relatively easy to install, especially when compared to some other types of cables. Its flexibility and smooth surface make it easier to pull through conduit and terminate at connections. Sixth, availability and sourcing is another advantage. THWN-2 is widely available from electrical distributors and suppliers, making it easy to source and procure. Seventh, consider the impact on equipment lifespan. By providing a stable and reliable power supply, THWN-2 helps extend the lifespan of the equipment it powers. This reduces the need for premature replacements and saves on capital expenditures. Eighth, environmental benefits can also be considered. By using a cable that is designed to last, you reduce the need for frequent replacements, which conserves resources and minimizes waste. Ninth, consider the impact on insurance costs. Using compliant and reliable wiring can potentially lower your insurance premiums as it reduces the risk of electrical accidents and property damage. 10th, peace of mind is invaluable. Knowing that you have selected the right cable for the job provides peace of mind and allows you to focus on other aspects of your operations. Remember, selecting the right cable is an investment in the long-term safety, reliability, and efficiency of your electrical system. TFFN-2 is a proven and trusted solution for outdoor industrial applications, offering a combination of performance, durability, and compliance. When making your decision, be sure to weigh all of the factors and choose the cable that best meets your specific needs and requirements. To summarize, when facing the challenge of finding an outdoor-rated number 16 AWG single conductor for control applications in an industrial setting, remember these key points. Firstly, NEC Table 310.104 does not list XHHW or equivalent single conductor cables in number 16 AWG for outdoor use, indicating that it's not the appropriate choice. Secondly, TFFN-2 cable is a suitable alternative as it is specifically rated for outdoor use, wet or dry locations, and has a 600 volts voltage rating, making it suitable for RMC conduit installations. Thirdly, machine tool wire, tray flame retardant and flame resistant nylon cable is primarily designed for indoor use and is not recommended for outdoor industrial applications due to its limited resistance to environmental factors. Fourthly, using the wrong cable type can lead to premature cable failure, increased safety hazards, downtime, compliance issues, and potential damage to equipment. Fifthly, when selecting TFFN-2, consider factors such as conductor material, insulation thickness, jacket material, and proper installation practices to ensure long-term reliability. Sixthly, other cable types like US-2, RHW-2, and XLP may also be suitable for outdoor industrial applications, depending on specific requirements and NEC guidelines. Seventhly, always consult the NEC and other applicable standards to ensure compliance and safe operation of the electrical system. Eighthly, remember that selecting the right cable is an investment in long-term cost savings, improved safety, enhanced reliability, and overall efficiency. Ninthly, consider the long-term benefits of using TFFN-2, including reduced maintenance costs, minimized downtime, and a safer working environment. Tenthly, peace of mind comes from knowing you've made the right choice and are providing a safe and reliable electrical system for your outdoor industrial application. By following these guidelines and consulting with qualified professionals, you can ensure that you select the right cable for your outdoor industrial control application, providing a safe, reliable, and compliant electrical system for years to come.